Hello everyone, my name is Kung Zhu, and I am honored to present our work, PromptHash, Affinity-Prompted Collaborative Cross-Modal Learning for Adaptive Hashing Retrieval, conducted at Xinjiang University. A fundamental challenge in cross-modal retrieval lies in the problem of truncated text semantics. Many state-of-the-art methods rely on pre-trained models such as CLIP for feature extraction. However, these models impose strict maximum input length constraints on textual data. For example, in the widely used cross-modal hashing dataset MS-COCO, the length of text descriptions can range from 169 to 625 characters, which far exceeds the maximum input limit of 77 tokens for the CLIP text encoder. As a result, a large portion of the semantic content is inevitably discarded, leading to severe semantic truncation. This truncation problem is not merely a technical inconvenience, it fundamentally undermines the model's ability to capture rich and nuanced textual semantics, resulting in the loss of critical information necessary for accurate cross-modal retrieval. Consequently, the generated hash codes become less discriminative, and retrieval performance suffers. Therefore, mitigating the impact of semantic truncation and effectively supplementing the missing contextual semantics have become major challenges in the research community. Addressing this issue is crucial for advancing the performance and robustness of cross-modal hashing methods, especially when dealing with real-world data characterized by long and complex text. To address these challenges of semantic loss and contextual redundancy, it is imperative to develop more effective strategies for representing and integrating multimodal information. Specifically, there is a pressing need for methods that can both preserve the essential semantics of long or fragmented textual inputs and adaptively filter out irrelevant or redundant context during feature fusion. Overcoming these issues is crucial for generating more discriminative hash codes and ultimately improving the accuracy and robustness of cross-modal retrieval systems. In light of these challenges, we propose a novel cross-modal hashing framework that systematically mitigates semantic loss and contextual redundancy by introducing adaptive prompt learning and gated fusion mechanisms. Our approach is designed to enhance the expressiveness of text representations, dynamically suppress irrelevant information, and achieve fine-grained semantic alignment across modalities. Previous cross-modal hashing methods have mainly depended on pre-trained models like CLIP, BERT, or Joule, stream transformer architectures to extract visual and textual features. But these methods face several fundamental constraints. First, mainstream pre-trained text encoders, for instance CLIP, have strict input length limitations. When dealing with long texts, this causes semantic truncation, and as a result, crucial information needed for accurate retrieval is lost. Second, in standard benchmark datasets, the textual annotations usually consist of discrete label words or concatenated category names. This leads to context deficiency and semantic redundancy, further weakening the discriminative power of the generated hash codes. Additionally, previous methods commonly use simple fusion strategies such as direct concatenation or basic attention to combine multimodal features. These strategies aren't enough to adaptively filter out irrelevant or noisy information. Most existing works also mainly focus on global-level semantic alignment, overlooking the significance of fine-grained, token-level consistency between modalities. In contrast, our proposed PromptHash framework overcomes these limitations through several key innovative features. We introduce a text affinity-aware prompt module. This module learns adaptive prompt tokens to enhance and re-weight text features. By doing so, It preserves foreground semantics and reduces the negative impacts of text truncation. Our hybrid SSM transformer architecture further boosts the model's ability to capture long-range dependencies and complex relationships in both textual and visual sequences. The Adaptive Gated Selection Fusion module enables a robust and dynamic fusion of multimodal features. It selectively keeps beneficial semantic information while filtering out redundancy and noise. Finally, our prompt alignment contrastive learning strategy ensures semantic alignment both globally and locally across modalities. It bridges the heterogeneity between modalities and promotes fine-grained consistency. Through these comprehensive improvements, PromptHash not only overcomes the main drawbacks of previous methods, but also attains superior cross-modal retrieval performance across multiple challenging benchmark datasets. Mainstream pre-trained models such as CLIP are widely adopted for cross-modal retrieval tasks, but they exhibit a fundamental limitation when processing long textual data. Input text is truncated beyond a fixed length, resulting in the loss of critical semantic information and the generation of suboptimal hash codes. This truncation, combined with the characteristics of commonly used benchmark datasets, where annotations may be limited to discrete category words or suffer from context deficiency and semantic redundance, poses a significant challenge for effective cross-modal retrieval. To systematically address these issues, we propose PromptHash, an affinity-prompted collaborative cross-modal adaptive hashing framework. Our framework is built upon a novel hybrid neural architecture that combines state-space models with transformer layers, leveraging the linear sequence modeling capability of SSMs and the expressive power of transformers to better capture long-range dependencies and complex feature interactions in both textual and visual modalities. Central to our approach is the Text Affinity-Aware Prompt module, which generates learnable prompt tokens by treating all non-category words in the text as trainable parameters. These prompts are encoded by the final layers of the CLIP text transformer, and their learned representations are adaptively fused with the original text features through a dedicated adapter module. This adaptive weighting mechanism ensures that the most retrieval-relevant semantics are highlighted, while background or redundant information is effectively suppressed, even in the absence of additional visual prompts. To further address the issue of context redundancy and negative information across modalities, we design an adaptive gated selection fusion module. This module integrates the advantages of SSM and transformer architectures with an adaptive gating mechanism, enabling the network to dynamically select and retain beneficial semantic information while filtering out redundant or irrelevant features during multimodal feature fusion. By jointly optimizing these components within an end-to-end learning framework, PromptHash effectively mitigates the problems of semantic truncation, context loss, and redundancy, leading to substantial improvements in cross-modal retrieval performance across challenging benchmark datasets. To alleviate semantic truncation and supplement missing contextual semantics, we introduce affinity-based text prompts to enhance the learning of truncated text features. Specifically, a learnable text prompt is constructed in which all tokens except the class name are learnable. The last two transformer layers of the CLIP text encoder are used to adaptively learn this prompt. The resulting prompt weighted text features are then adaptively fused with the original text features via an adapter, thereby emphasizing retrieval, relevant semantics within truncated text, and optimizing retrieval performance. This approach achieves significant improvements without requiring additional visual prompts. To address the limitation of redundant information across different modalities, we design an adaptive gated selection fusion module to reweight and fuse multimodal features, enhancing retrieval, relevant semantics, while suppressing negative semantic information. Specifically, AGSF combines the strengths of state, space models, and transformers to adaptively select and retain beneficial semantic features from both modalities, while filtering out redundant contextual information that may hinder retrieval performance. The table presents the results of the ablation study. The experimental results demonstrate that the proposed top module effectively addresses the problem of text semantic truncation. By adaptively reweighting the original textual semantic features, top retains retrieval relevant information while reducing the negative impact of irrelevant features. Furthermore, the fusion of visual and textual semantic features enables the selection and preservation of beneficial semantic information from both modalities while filtering out redundant contextual information that may hinder retrieval performance. Finally, by aligning global and local prompt tokens with an image-centric approach, the model optimizes both prompt and original text semantics, resulting in high-quality hash codes. The table presents the results of comparative experiments and ablation studies for the proposed method. The experimental findings demonstrate that the top module significantly alleviates the problem of text semantic truncation and enhances the expressive capacity of textual features. By adaptively reweighting the original text semantics, top effectively highlights retrieval relevant information while reducing the negative impact of irrelevant features. Furthermore, the AGSF module enables adaptive fusion of visual and textual semantic features, allowing the model to retain beneficial information for retrieval and filter out redundant or negative semantics that could hinder performance. Through the alignment of global and local prompt tokens, the model further optimizes the quality of the generated hash codes by adaptively reweighting the original textual features, thus enhancing the prominence of foreground semantics and suppressing irrelevant background information. As shown in the table, PromptHash achieves the highest results on all metrics for the NUS-wide dataset, with map et al. Significantly surpassing the best existing methods. For example, on NUS-wide, the image-to-text retrieval task outperforms VTPH by 18.22% and the text-to-image retrieval task by 18.65%. These comparative results demonstrate that PromptHash delivers superior performance and robustness across different datasets and retrieval tasks. Overall, PromptHash consistently achieves state-of-the-art map scores on all benchmark datasets, and the ablation study further confirms that the top module effectively alleviates text semantic truncation, while the AGSF module adaptively fuses multimodal semantics and filters out redundant information, validating the effectiveness of the proposed approach. We compared our proposed PromptHash method with 10 state-of-the-art approaches. Across all metrics and on all three benchmark datasets, PromptHash consistently outperforms the competing methods, with its curves surpassing all others. These results demonstrate the effectiveness and superior retrieval performance of our approach. In our study, we observed that all three commonly used public cross-modal hashing datasets contain substantial noise that adversely affects retrieval performance, with the issue being particularly prominent in the MS-COCO dataset. Moreover, the text annotations in the other two datasets are based on discrete word labels rather than natural sentences. For future work, we propose to optimize the original annotated texts and images by leveraging diffusion models for image enhancement and employing large language models such as GPT-4 to reconstruct text annotations into prompt-like sentences. Additionally, we will explore integrating weakly supervised segmentation techniques, introducing KM-based image prompts as retrieval targets to further improve retrieval performance. I would like to acknowledge my co-authors, Shu-Li Chung and Jiayi Chen, for their valuable contributions to this work. Thank you for your attention. I am happy to take any questions.